I did my oceanography bachelor and master's in University of Florianópolis in the south, and Santa Catarina in the south of Brazil. But since 2016, I've been working as a software engineer on completely unrelated things, but very closely to data science. I have a Brazilian podcast in Portuguese, unfortunately, about data science, which is the one I'm logged in this Zoom. And so I'm here today to talk a little bit about the 4 most known libraries in Python for data analysis. But before I start, I know that a lot of people are not with their cameras on, so you could share, hey, raise the hands on Zoom, kind of like who has contact, like who knows programming, who has programmed before, who has any idea of that, or who hasn't, maybe. Who has? Okay, so a lot of people, great, okay. I'm gonna try to go slow, but not so slow that you have an understanding, but if I'm going too fast or if you want anything, please feel free to interrupt me and ask questions. Sounds good? Okay, cool. I'm gonna share my screen. Okay. Can you guys see? Yes? Please don't leave me talking by myself 2 hours. Talk with me. Okay, so I'm running the Jupyter notebooks on my computer, so the environment is a little bit different than what Emilia just showed to you, but it's the same idea. One of the major things that a Docker and the combination of Jupyter Hub and the Docker does is allow to transfer this thing that I'm running in my computer and run it to a lot of different people that can be accessed over the internet. So Jupyter was kind of like a revolution in terms of data science and Python. Well, right now Jupyter has kernels that allow Julia and R and like a lot of languages, but it started as a project to make something more iterative and more visual for people that, like us, are working with data. And so Jupyter works with the concept of cells, and each cell is individual, but they share a context. So in this case here, I'm in one notebook. So all the cells in this notebook share a similar context, but they are individual on their own. So for example, if you see here, I am selecting one cell, and you can look here that it's a markdown. So the cool thing about Jupyter notebooks is that you can intercase, like you can make one cell of code and one cell of text, and you can do like a notebook, but your code actually works there, and you can see not only the results, but charts, anything you really want. So for example here, if I double click, you can see here that I can edit the text, edit, and I can use the button here, run, to run the cell, and it gets interpreted as a markdown. So pretty useful. For those who doesn't have a lot of context and familiarity with Markdown, I left a cheat sheet here, but it's pretty simple. You have like hashtags for titles, like I forgot the stars, I forgot the name of this, for bold and italic. So it's pretty straightforward.
Leticia, can I suggest that
yes?
you increase the font? Can you suggest that you
thanks.
increase the font a bit? And also
Is this better?
Comment on a question you made earlier. People wanted to say whether they have experience programming. Everyone is muted by default. Everyone except us organizers. So keep that in mind.
Okay.
You're not going to get reactions from people.
Good to know. Thanks for that.
But
okay,
I'll get
great.
presents to give you feedback. And just one last thing, if you go on view and you remove the toolbar and the icons, you get more real estate screen to show more stuff.
Oh,
yeah, toggle
toolbar.
Header and toggle toolbar.
Okay. Is this better now?
You can
Okay.
change, you can remove the header as well, and then you get more space.
Okay,
Yeah.
amazing. Perfect. Thanks, Felipe. Thanks, Emilio. Okay, so you can see here, each cell, I have 3 cells of text here, but now here I can see, oh, I can see, I need the toggle bar for now. I can see here that
Sorry.
I now, that's okay, that now I have a code. So this cell contains code. And so, for example, if I use the hashtag that in Markdown is interpreted as a title, here, because it's code and I'm running, you can see here on the left side that I'm running Python 3, is actually a comment and not a Markdown title. I can use Control Enter for running the cell, or I can use this button Run over here. Both of work pretty fine. So Control Enter will run the cell, and you can see here that we have numbers that increase. So you can see which cells were run previously than others. Because as I told you, the cells share a context within this notebook. But if I run a cell before another one, the code on the, if I run this thing here without running this thing here, anything that is declared here won't work here because the cells are not in order. So as I told you as well, I have here, for example, if I want to print the cells, the cell contains also the outputs, the printing outputs, and it always contains the last thing. So the last thing that's on the cell will be printed always, unless it's stored on a variable. So you can see here that I have number 3, this code run, and now again I have text. So this is one of the major things of Jupyter. You can do whatever you want. And so because of that, we can actually, for example, give explanations and mathematical formula all together on the same notebook that I'm implementing those. So for example, if I want to write a formula, I can use LaTeX, and it's the same thing as I would do in LaTeX, but it's when I run the cell now, it gets interpreted pretty quickly. Okay, a little bit more. So we saw here on the first cell here, I imported Matplotlib, which is the library of visualization. And I did this magic here. So there's something here that is not normal on a Python code, but this is what we call Jupyter magic. So Jupyter has a lot of plugins that you can add towards it. So you can actually work with a lot of extra tools that don't get configured by default. So in this case, what I'm saying is by default, any chart, any graphic image produced by Matplotlib is not going to be shown on the Jupyter. So basically with this thing here, I'm allowing it to actually plot a chart. So I'm going to run here this cell, and you can see here now that I can plot a chart. I'm just a random chart, but you can see that I can visualize this here. You can actually add videos to Jupyter Notebooks, which is pretty fun. I have a 10-hour of ping pong playing here. It's pretty amazing. So that is the, and this is just like scratching the surface of Jupyter Notebooks. It's a very powerful IDE, very useful. And I want to give you an example of what I consider a really good use of Jupyter Notebooks for oceanography. So Lorena Baba is a professor from a university in the US, and she created this 12, it's called 12 Steps to Navier Stokes. And if you go here, I'm just going to open the first one. Basically, each step is a Jupyter notebook that contains an explanation of, for example, linear convection in this case with formula, and then the implementation of the code. So everything works together, and then plotting the wave and like everything. You can see there's a lot of formula in here, and then it ends with a video about how to implement this and how that works. So pretty useful usage of Jupyter Notebook for oceanography. I highly recommend you to check it. Okay, I'm not sure if we have questions on this Slack so far.
We do have a question. It was more,
Okay.
hang on, let me pull it up. It was more on what Emilio was talking about before. It was, does the authentication HTTPS versus SSH on GitHub matter? I use SSH with GitHub. Maybe I shouldn't.
Should I take that? Since my name was mentioned, I will go ahead and take that.
Yeah, but feel free.
Go ahead.
Yeah, feel free to say it.
I'll go for it. So this is referring to something I said when cloning a GitHub repo. That's because there are two options when cloning. The default typically will be the HTTPS, and the other one is SSH. It's not that one is better than the other, but for people who are new to GitHub, HTTPS will be simpler. If I remember correctly, the SSH cloning involves creating SSH keys and setting them up on your computer. If you have that done in your local computer, great, go ahead and use them. But on the, it doesn't matter. On the Jupyter Hub, you won't have that unless you're really diligent and load them. So it's just easier to do HTTPS.
Thanks, Emilio. Any other questions?
Sorry.
No?
Hello. Yeah, I have a question.
Yep.
I don't know if you can hear me. I'm a little bit lost. Where is the Jupyter notebook? I can't get into the. I don't know what is this. This Jupyter lab, and I have a code. I can generate a code, but I mean I cannot see if it's the same thing you are doing in your example now. I don't understand.
Okay. Did you clone the repository?
No, perhaps that's the part I'm losing.
Yeah. Yeah. So when you clone the repository, I'm not sure if you were here when Emilio showed how to do that. Basically, you're gonna have a folder called data analysis modules. And inside this folder, you're gonna see all the notebooks that I'm using here, and you'll be able to work with them.
Okay, I will try. Yeah.
Leticia, if it's not too much of an imposition for you, would it be okay if you used Jupyter Hub directly? Again, if it's disruptive to you, I understand, but that way people will be seeing exactly what they should be seeing on their computer.
It makes sense. Just a second, I'm gonna get the link here.
And by the way, she's going through the process that everybody has to go. So those who are not on the same point yet, try to follow along now, because it'll be exactly what you had to do.
Okay. I'm signing in with GitHub. I think I already gave my authorization on the previous moment. Oh, cool animation.
Okay.
Okay,
so that was really fast.
I spun it up before.
Okay, and I would suggest to increase the font so that people can see clearly even menus. So that'll be really helpful.
Okay.
I think that's good.
It's good? Okay, cool.
Yeah.
So I'm gonna go to the Oceanhackweek pre-week code. Let's use HTTPS as we just learned. I'm gonna copy it here. So git clone and the name of the repository. Cool. Not sure. Okay, now if you go here, you can see that we have the folder. We have the data analysis modules, and you can see here the first notebook. Cool. So the things that I showed you still work, I think. Control Enter, it runs the cell. You can see that the cell is running because it has a star here. It's really fast now, but I'm gonna try another one. I'm not sure if you were able to see, but that is indication that the cell is actually processing something. Can I remove? Yeah, that's okay. Status bar.
Leticia?
Okay, yes?
I'm sorry, this is Shell. There's a question on Slido.
Okay.
That they're using, this is Megan, is using the Jupyter Hub, but she's confused on how to open the notebook. Can you just show that again, maybe?
Yeah. So I went to this folder over here, file browser, as it's written. Oh, I'm gonna go back here. Here you'll see, if you clone the repository, you'll see the Oceanhack pre-week folder. You can see that it's the same name that it's here. So we can see that it's the same name of the repository. And once it's here, it's simply a matter of opening a file as you would normally do. Double click here, double click on data analysis modules, and then double clicking the file itself.
I'm sorry
not
to interrupt.
sure.
Yeah, sorry.
Sure.
I'm sorry to interrupt again. I get lost just in the part of cloning. When you clone, that you did very quickly in the terminal. So I didn't know how to get the GitHub.
If I may, we this could get messy pretty quickly if you're having very detailed problems and interrupting Leticia. Please ask the question first on Slack. And there'll be people monitoring that will try to help you directly with those individual. We have mechanisms for helping you. For example, we Slack video. So we can spin up a Slack video where someone can show you specifically how to do things. Or we may decide if there are common questions arising, we may decide that we can open up a breakout room. Although that doesn't make sense because you want to be listening to Leticia. Anyways, please start on the Slack. And there is some technical glitches here. The setup was supposed to not enable participants to unmute yourself. So please be very cognizant, I guess, of if you're asking a question, start on Slack rather than unmuting yourself. We'll let Leticia say when she'd like to take questions so she can control the flow.
Okay, perfect. So, okay, I think I know this could take like forever, so I could be more detailed, but I'm gonna focus on the other libraries. If we have a question, we come back to Jupyter, okay? So if you go back to the browser, open the second notebook, NumPy. And yeah, okay, great. So NumPy is, let's say, the basis of all data analysis in Python, I think. It's basically the numerical Python module. It has some power features because I'm not sure if everybody's familiar with Python, but Python implements the concept of lists, which is basically 1, 2, 3 objects inside of, like as many objects as it can possibly fit inside this list. And the object can be anything, like another list. But because it doesn't have the concept of vectors, arrays, and matrices, it becomes pretty complicated to do this kind of things with pure Python. So basically what NumPy does is implement these concepts of array, vectors, very similar to what we have in MATLAB for those who have some experience there. So a common terminology is importing NumPy as NP, just for shortening. So it's really common for you, if you see NP, it's normal for you to understand that this is NumPy. And so it's really helpful for you to keep this pattern. So anyone seeing your code, if they see NP, they understand that you're using NumPy. So I'm gonna run Control Enter for running this. Okay, now I have NumPy available. So as a Python library, it is not available by default. And I can create a vector by passing a list. So this is a Python list. and I'm passing this to an NumPy array. So if I do this, you can see now that the vector type is an array. And okay, so what does that mean? An array behaves very similar to lists in some way. So for example, I can slice one by using the same terminology as I would do in a list. So what it gives me is actually in a smaller array, but still an array. But it also implements some very useful methods. So for example, in here, I can see the vector maximum value, the mean, the standard deviation, variance, and some other things. One pretty interesting thing that you can do is you can do dir and vector. This is not on your notebook, so if you please write it down or do it on your notebooks. You can see here that you have a lot of things and a lot of other libraries and things that you can do, like you can sum, you can shape, there are so many things. So this is a useful thing. I'm going to just delete this so it doesn't pollute everything. So in Python lists, we have one value, right, like length, but here I have a shape. So in this case, because it's a vector, it has size 4, so 4 columns, but 0 row, like, yeah, it has 1 dimension. So because it's only 1 dimension, it is shown as just 4. And I can actually manipulate this to go back to a list. So NumPy has all these interesting methods that can go back and forth. And one pretty useful thing that we can do is, for example, I can create a variable called isBigger, and I can pass vector is bigger than 3. If I do this, let's print here, it's bigger. I don't know if you remember this, but if I just put the name of the variable, Jupyter Hub will actually print the variable. I don't even need to put the print. So I'm going to run this. And you can see here that it's also an array, but now it's an array of booleans. So false, true, true, and false. And what NumPy allows me to do is actually filter my vector considering this array of booleans. And if I do this, it will only return the values that were bigger, that were true in the array of the filter. So let's double check this. If I print vector, I will see that the first one was false, so it didn't print here. The second one was true, and then it's here. And so we can do this logic, creating arrays of booleans, and then filter the data set, the array based on this. And then again, we can go and do matrices. And basically, a matrix is an array of 2 lists, right? And so in here, I'm passing 2 lists inside the list to an array. And now I have a matrix. So I can see here, it's organized. Visually speaking, it looks very similar to Python lists, but it's completely different in terms of like the methods, the things you can do, and how easy it is to manipulate them. So I can do here, for example, matrix maximum. Imagine if you had only lists, you had to like iterate through every single one of them. It would be a fairly complicated thing to do. And now because I have a 2-dimension array, now the shape is actually gives me 2 values. So number of rows and number of columns. So because as I told you, I have all of these functions. For example, I can reshape my matrix for something else. I can transpose it. I can flatten it, and so many more. So NumPy is this basic structure that implemented all of this logic. Before I go further, do we have any questions? Yes?
We have a couple questions.
Okay.
One is, you seem to be able to add a new cell very fast and easily. How did you do that?
Oh, sorry. Yeah, so, okay, one thing. You can see here that we have a cell in blue. This means that I'm actually editing the cell. If I press ask, oh, it doesn't do anymore. Okay. I'm very old on this because this is supposed to be different, okay? Okay, so if I press ask, I'm not editing anymore. You can see that the cursor disappeared. Now I have a couple of quick shortcuts that I forgot to show you. Sorry, thanks for the question. So B of below inserts a cell below. And if I press A, it inserts a cell before, above, right? And for deleting, it's just DD and it deletes. You have all of these functionalities in here. You can where is it? Oh, you can add here or cut one or copy and paste one. You have all the functionalities here. But I find it very useful, the shortcuts Control B to run the cell, B to create a cell below, and DD for deleting a cell. But always make sure like that if I'm to not be editing the cell. So for example, in here, I'm editing. If I write B, it just writes. So I press ask and B, and then it goes and inserts another cell. Oh my God, I'm deleting everything. Where is the undo?
It was up at the top.
Thanks. Okay, do we have another question?
I think the other question was effectively the same question, how to add a new line of code. So that's what you were.
Okay, thanks.
Yeah, that's all the questions right now.
Okay, great. So right now we can enter the matrix operations that NumPy allows us to do. So for example, in here, I'm gonna create two matrices of 2 and 2. I can see here that I have this 2 matrix. So the first thing we have to understand is, oh, not right now. Yeah, okay. So the first thing we have to understand is the concept of axis. So NumPy specifically implements the concept of axis. So each dimension of an array is an axis, and it always starts with rows. So rows is the axis 0, then columns is axis 1, and so on and so forth. So for example, in here, I can use the function concatenate. I'll pass these 2 arrays, 2 matrices, and you can see here that axis 0 is actually the default value. So you can see that because it's gonna do the concatenation in axis 0, it will actually put them below. While if I concatenate on axis 1, which is columns, it's gonna concatenate on the side. So this concept of axis is pretty important because I've ruined some things doing the wrong axis, or it doesn't work and I never remember why. And this is a big reason because we're used to having everything in columns, but the axis of default is rows. So sometimes that can be pretty tricky. Another thing that we can do with NumPy is creating default things. So we have a range, which basically implements, in this case, I asked it to implement from 1 to 6 every 0.33. And so it creates as many values as I need so it can be implemented. And a couple of things here is there are some things that you can force a type. For example, I could force it to be an integer or a float or whatever type you need. In this case, it's only useful to do a float. For those who don't know, float is basically a number that has decimals. That's the only difference. NumPy also allows me to create, for example, arrays of zeros, pretty useful for counting, arrays of ones. And you can see here that in this case, I forced it to be an integer because I didn't want 0.0. I wanted to force it to be an integer. And it also has the identity matrix, which is pretty useful in some cases. So we don't have to worry. We just have to pass how many columns and rows we need. Okay, so another problem that we have with the lists, like using pure lists for analysis, for data analysis in Python, is the fact that if we want one operation to be done on every single item of the list, I have to iterate over the list to do this. In this case, NumPy does a very similar thing that we did in MATLAB, which is concatenation and operation of matrices. So in this case, if I have two vectors here that are 1, 2, and 3, then 5, 2, and 6, I can sum them. Oh no, sum them, diminish, reduce, multiply. Basically, all the operations are available, and they are being done considering the array. So each element will be matched with the other element of the array. But at the same thing, I can do, for example, a times 2, 3. I'm gonna use this operation in every element of the array, which is something that Python list doesn't allow you to. If you do this with a list, it's gonna fail. So that's why NumPy was kind of like a game changer in terms of how Python is used for data science and data analysis in general. It also has default values, for example, pi and the epsilon, I think it's epsilon, not a number. That is basically an indication that there is nothing there, is the nothing equivalent of data analysis. Infinite, and some useful functions, for example, if I want to check if an array, so for example, in this case here, I want to check which values are not a number. In this case, what I can do is actually filter the data so it doesn't have not a numbers, for example. And we have some even more magic. For example, I can extract only the diagonal of a matrix, for example. And in this case over here, I can actually, okay. So I can actually do one operation per item of the array. So there's a bunch of magics. There's a bunch of things. NumPy had its documentation refreshed a couple of weeks ago. So it's pretty good, much better than it was in the past. So I highly recommend you to check this. And with this, I talked a lot and very fast. I'm sorry about that. But do we have any questions? Pandas and Matplotlib are going to be much more complicated.
I'm not seeing any questions right now.
There should be one.
What?
There should be one. I asked the question, but I can ask here. Can you talk about the matrix multiplication operator?
What do you mean by that specifically?
How can you do matrix multiplication with NumPy?
Okay, so I forgot the name in English. What is the name in English? Oh yeah. Okay. Cool. Thanks. So in this case, if I put A dot B, I'll have here the multiplication of matrix as well. Thanks. I forgot about that.
Sorry for putting you on the spot.
I completely forgot. I'm sorry. It's been forever since I've done this.
We have a lot of people coming from MATLAB, and MATLAB, the natural format for the data is matrices, and NumPy is arrays. So people get confused about that. Okay,
yeah, that's true. That's true. This is one very big important that not only NumPy, and we're going to see in Pandas as well, that the arrays is the main source of truth. And it can be quite confusing in the beginning. Can I go to the next notebook? Yep, okay. Okay, so I introduced you a little bit about NumPy, but now we're gonna talk about Pandas. So NumPy is extremely useful, extremely fast, like super cool. But for a lot of people that were coming, for example, from non-data specific areas, they could be quite complicated and quite magic in some terms. And so what Pandas did was basically construct something on top of NumPy that has a little bit more functionality and has an interface that is a little bit more friendly, especially for people that are not very familiar, for example, with matrices and arrays and everything. So what happens with Pandas is that in MATLAB, for example, one thing that's really painful is mixing, for example, data, numbers, and strings and text, right? Like it's pretty painful. And NumPy doesn't take the advantage of Python of being able to mix and match as well as you'd like. So, okay, so let's do a couple of things. First, we're going to import the same way we have, I don't know what this is here. The same way as we have NumPy as NP, we use Pandas as PD. Okay, I imported. And now instead of an array, Pandas introduces the concept of series, which is basically an array with superpowers. So in this case, I am going to be doing an array of strings. And you can see here that in NumPy, when we created an array up here, when I created an array over here, let's print this. It is an array. It's in a list, and that's it, numbers or strings or whatever it is. In terms of series, it already gives some indexes. So Pandas, the Pandas series actually introduces the metadata on the array already together, so you don't have to worry about that. And this index can be anything. So for example, in here, I'm going to create a series of 5 random numbers, and I want the index to be the first 5 letters of the alphabet. No, yeah. And you can see here that I have this. And this is pretty useful because you can have information that is important, but it's not necessarily, well, it's metadata, right? So it's pretty useful in a lot of cases. For example, if we're dealing with a time series, time is super important. So you can never unattach time to the value, and you can't really do that without 2 arrays in NumPy. But in Pandas, you can do this as one series. Timestamp will be the index, and the value will be the value. So it's pretty useful, and that's why I call it NumPy with superpowers. Okay, because series are built on top of NumPy, not all, but like I think all, but a lot of things from NumPy are valid on Pandas. So in this case here, I'm creating a filter. So this is gonna result in an array of Booleans. Everything that's bigger than 0 will be returned true. Everything that's lower than 0 will be returned false. And then I can use this array to filter my series the same way I showed you how to do it on NumPy. So here, And you can see here that the index, they are there, they are not lost. So you have to actually force it to rebuild the index if you want that. So you can mix, match, and reorganize and do a lot of things with the data, but the metadata of the index will always be there. And that's pretty useful, especially, for example, in time series. The same way I can do this with more complex things. For example, I can get all the values that are above the median, and there it is. And you can see here the index are there. I'm gonna stop here a little bit. Was this clear? Like, do we have questions?
We had two questions. One was related to the previous tutorial about NumPy broadcasting, and one is how to read a comma-separated file. The comma-separated file, I think it's coming next on your Pandas port. But if you can talk very briefly about broadcasting, that would be good.
About what?
NumPy broadcasting.
I don't know about that. I'm sorry.
No problem. We can answer those on Slack later. It's when you have one matrix with a certain shape, and then you have a vector, and NumPy will fill that for you.
Ah, okay. Sorry, I'm not familiar with that. Okay, so about the CSV files, Excel files, we're going to see that on the next notebook. So hang with me. Okay. So I can get a specific value of a series by calling it by their index. So in this case here, if I want to take, this value over here, I just pass it as I would for example, a Python dictionary, and I can get the value here. As the same thing, we can actually use a function get that will try to get an index, but if it doesn't exist, I can pass a default value that it will return. So in this case, I'm trying to get f. F doesn't exist on my series, so it's going to return none. And if I change this to 0, it's going to return 0. That is one function that, because if I do this, but I try to get a thing that doesn't exist, whoops, it's going to give an ugly error. So to avoid that, we can use the function get and pass a default value so we don't get a nasty error. Okay, and as I told you, series have concepts of metadata. So we can also name our series. And so in this case, I'm going to call it numbers, and now I have a name for it. So I can get information and remember that in every step of the process. And I also get the type of it. So each series usually can have multiple types, but it should usually have only one type. Okay, so there are a couple of interesting things. The first one is Batman. But nuns, I think most of you are familiar with MATLAB and not a number in MATLAB, but Pandas implements a couple of interesting things. So in this case here, I left two numbers as a num, and I can simply use the method interpolate and with the method linear, and there is a bunch of things, and it basically interpolates that for you. So this here, you have a ton of those. It's pretty useful, but that is one of the powers of Pandas, is actually to implement a bunch of methods inside its own series. So you don't have to go try to find another library that does this. It has it inside it. And that was it on series. Do we have questions?
No more questions.
Okay, so I'm gonna go to data frames and CSVs, and we're gonna have some fun. Cool? Okay, so if you open the next Jupyter notebook, I'm gonna just close this over here. Okay. Okay, so we talk about NumPy and arrays and matrices, and then we talk about pandas and series. So series is the equivalent of an array, while data frames would be closer to matrices. So basically is a two-dimension matrices, but it's, for me, it is closer to an Excel. So it will be the Python equivalent of an Excel for that I call it. So basically what happens is a data frame is a series of Pandas series that are linked together in one huge matrix. So let's import pandas here. Okay, so in this case, I'm gonna pass a dictionary. So this curly bracket indicates a dictionary. I'm gonna pass values as a pandas series that has 3 elements, and categories. It's also a pandas series that have 3 values, but one is integer and another one is string. And I pass this to the pandas function data frame. Okay, so you can see now that we have a nice structure. The indexes are created automatically. The names on the dictionaries are here on the top, and the values itself are here. So pretty similar to it is still a matrix, but because it has all this metadata on top of that, that's why I call it a little bit more close to Excel. Okay, and Pandas also has this function of reading CSV. So in this case, I already brought this World Happiness Report CSV. But if you take a look, oops, read, I think, yeah. So you can see here, we can have Excel, a bunch of data, HDF, HTML, JSON, Parquet. So there's a lot of things that it already knows how to load. I'm gonna show you only CSV, but it's basically almost any data format it can read. So in this case here, I'm gonna open here, and that's it. So because it's a CSV, because it's a comma-defined file, because a lot of things, it already interprets the column names, the values, everything. So let's take a look. We can use the function head to show the first 5 rows. Sorry. Okay, great. So we have here the automatic index that we have here. We have the column names already understood as column names. Because it has this beautiful structure, we can see that there's like beautiful colors and I can see things. Perfect. I have one series of strings, one series of integers, we have series of floats. Pretty useful. And we can also see the tail. The tail would be the last rows of the file. Okay, so you can see here that the index is much, much bigger, but we still have the same idea. So both these functions can, you can pass how many lines you want to see. Oh no, I just want to see, oops, 1 line, because I just want to make sure that the CSV is the right one and everything. So pretty useful functions. So we can extract, for example, the name of the columns by passing df columns and values, and we can get the matrix shapes, for example. Okay, so I have here this is a list, a Python list of column names. So I can, for example, iterate to read or anything you want, and the matrix size. And one function that's pretty useful for, especially when you're opening a CSV that you have no idea about, is this describe function. So basically the describe will take all the numerical series or columns and give all the information. So the count, the mean, standard deviation, minimum, 25% quartile, 50% quartile, 75% quartile, and max. And the interesting part here, in this case, we don't have anything, but this count doesn't count not a number. So you can see here actually different numbers if you open a CSV that has empty, not a number values. So pretty useful. Like usually when I'm opening a CSV that I've never opened before, this is the first function I will do to get an idea of what's happening there. I'm gonna stop there. Do we have questions?
There's no specific questions on Slido. Oh wait, a question just appeared.
Okay, great.
How would we add our own CSV to the Jupyter Hub?
Oh, let's.
I
think
can
it's
take
here,
that if
right?
you want.
Okay.
Or you can, either way, I just didn't know if
you
want to answer questions about Jupyter Hub.
Right? I think it's uploading. Right? Am I right?
I forget.
I guess there are many ways. Like, yes, you can upload it via the interface. You can put it on a repository and clone it. You can read it directly from the internet because the read CSV on Panda reads from a URL. There are so many ways that's actually hard to answer that question. It will depend on where your data is.
Let's do the most simple one. I can click here and browse through my files and find a CSV and upload it, right? I don't think I have a CSV here.
And I will add, I actually didn't know that in Jupyter Hub.
Me neither, that's new for me.
Did you say it's new?
It's new for me as well. I didn't know about that. I learned two things. I learned that series can act like dictionaries. You can use the cat and have a default value. I had no idea that was possible. And that you can upload stuff to Jupyter Hub.
Yeah. It's with series is more easy. With data frames, it gets a little more tricky. Although I haven't seen Pandas 1.0, like how that goes. Oh, yeah. Okay, so for those who are not familiar, Pandas stayed for a long time in 0-point-something versions, and they launched the major 1.0 version a couple of months ago, I think, or a year ago, where they made this huge rewrite on a lot of things. It's pretty beautiful. So it's kind of like an even more steroid Pandas.
And I just add briefly, not on Pandas, that questions are being asked on the tutorials channel directly, and some of us are answering them directly. If there are questions we haven't answered there, we'll try to bring them up when Leticia stops for questions.
Okay, amazing. Okay, cool. So now we have columns. So, okay. Remember that I told you that data frames were basically series that are combined together with the same index. Because of that, we can actually use everything that I showed you on Pandas series, but for each column here. The only thing is that I'm gonna use this, I never know the name of this, but this thing here, and passing the name of the column. So in this case here, I want to get, not this one, but I want to get this series here. And you can see here that I have the mean. And if I just pass this thing, oh yeah, I have to pass type. You can see that it's a series. So basically, everything that I showed you on series are useful in columns here because columns are actually series. So that is a pretty useful information that you should remind from everything that because series uses a lot of NumPy arrays, and data frames is basically a bunch of series combined together. That's why I construct the tutorial in this way. So you can see that everything that I showed you so far, it's useful and in any of the places that I showed you. Okay, so we can do the same thing. So for example, I'm taking here, I want to get, so this is a series where the last evaluation is higher than 0.7. So in this case, what I'm doing here is creating a filter, so an array of Booleans. So let's do this separately. Oops. Why are you not working? Okay. If I pass this, sorry, I'm having some trouble. Okay. Higher than 70. Okay, you can see that an array is a series of Booleans, but I can pass this series of Booleans inside my whole data frame. So I'm filtering all the columns, considering one column only. So if I do this, you can see that actually I have a smaller data frame that has only this number of records and not this number of records, because I'm filtering all the data frame considering one column only. I can also do this considering two filters. So this will give me a Boolean series. This will give me another one. And I can say, I want on the data frame, every data that has this equals true and this equals true. And so we're gonna see that the number is much smaller. And the same with OR. So this is an OR and this is an AND. Oh, you might be wondering, what if I want the inverse, right? Like the opposite. If I want the opposite of this, I can actually do the exclamation point. Oh, that's not it. Sorry. It's not. It's not? Okay, I don't know how to do it. I'm gonna search for it. They changed it somehow. Okay, sorry. Okay, another useful thing that this is like my go-to function as well is value counts. So basically I'm taking one column, one series here, and I'm using this function value counts that will actually give me the number of values. So in this case, salary, I don't know if you remember, let's pause here, but yeah. Oh my God. I spilled coffee all over my keyboard today, so it's kind of crazy. I'm sorry about that. I think it's ruined. Okay, so you can see here that salary is actually values that are not integers or floats, numbers, but they are strings. So because of that, I have this function value counts that will actually count the number of occurrences per category. So if I try to do this on a numerical series, that doesn't make sense and that's not available. So that is another thing that we have to understand with series is which is the type of series that we're dealing with and the functions and methods that are available within it, considering the context of it. So in this case, this is pretty useful if you want to have an idea of how is the distribution between categories. I can also use the function drop to delete a series. So in here, and here is where we have the one thing that for me is very confusing, which is I always work with the concept of columns. So columns are the main thing and each row is one record. But because axis, remember, I don't know if you remember from NumPy, axis zeros is row. If I want to delete a series from my data frame, I actually have to pass this axis 1 to make sure they are deleting the column. So if I remove this, it's gonna give me an error and it's like there is no left found in axis. Like how can it not? Like, so you have to specify actually specify the axis here. And so we can see here that we don't have any left column here. So that's why sometimes if you find a problem with axis, like if you find something like this is not found in axis, like this may be the problem, and it's pretty annoying, especially if you consider the importance of series. I'm going to stop again. Do we have more questions?
I'm not seeing any Slido questions. There's some that are being fielded through tutorials. Are there any that haven't been answered? People that are monitoring that.
There is one that was answered, but maybe if Leticia can comment on something, because in my opinion, this deserves its own tutorial per se, but how pandas handle dates.
And times.
Okay.
And times.
Pandas, dates and times. Okay. So let's get something here. So I'm trying to remember if I can do this. So when you have a date like this, for example, sorry, my number is not working. Let's try. I think I forgot exactly how that works. Let's do this.
But while she's doing that, add that there's no one single 30-second answer.
Yeah.
There are many aspects of handling date times.
Oh. Yeah, it's not working. Oh yeah, because this is not us. Okay. So I'm constructing here a data frame. Oh no, I renamed it as ZF. So if we get here, I forgot the we can have, I think it's to date time. I think I have to do PD to date time, and I can pass DF. Oh, I think I have to pass the series. Yeah, so, oh yeah, I forgot to tell you that I can either call a series like this, or just like this, but this doesn't work if you have spaces in it. So be careful when accessing your columns. So in this case, for example, I pass it as a simple string. I use the function from Pandas called toDateTime, and I pass the series. And because it already has an idea of how a datetime works, it already transformed this to a date. I'm pretty sure that if I do like 000000, this still works, because it kind of deals with that pretty well. So there's a couple of things. It depends a lot on how your data is structured and if it's in a format that Pandas interpret, but there are a lot of functions to handle that. I hope I answered the question. I'm gonna assume yes, unless spoken otherwise. Okay, so I'm gonna continue. We can come back to dates in the future. So we can use a function called, I'm gonna just, because I destroyed so this is a good example. So I renamed something else as a DF. So basically now everything that I've done before is lost because I renamed the variable. So I had to go back and run this. So now I can go back and continue with what I was talking about. Okay, so we can rename columns. We can see again the top of the head. We can see that something is different. And now it's another thing, that's another concept that Pandas implements that is really important for us to think about, is the concept of in place. So what happens is every time you apply a function to a data frame, it will create a new data frame with that function implemented. So for example, in this case here, I renamed this function. So I renamed numberProject to numProject. But if I try to see the column names of DF, you see that numberProject continues to be there. So this function actually created a new data frame, you know? So I didn't actually implemented it. I was just like seeing that this solves and this is stored in a new data frame. So what happens is if you want to actually update your data frame, you can use this concept of in place equals true, which means that if I do this now, numProject is there, but if I get the column names, okay, we'll see here that is numProject. So if you're working with a huge CSV, a huge data, and like keep creating new data frames is going to kind of blow up your computer's memory, you should always use in place to make sure you don't blow up your memory. The problem is that if you're doing a series of complicated things, always on in place, and you do something wrong, you had to start all over because the in place doesn't give you the option to go to the previous implementation. So make sure you you see what do you need and the size of the CSV you're working with. Sounds good? Okay. So as we were talking before, let's go back a little bit. So if you remember in series, to get a value, I could access one like this. But now we're not talking about a series, we're talking about a series of series, like an asset of series. So what I need is, if I want to take a row, which is one item of each series that are on the data frame, I have to use the function iloc. So in this case, iloc will give me this result here, which is the values for each column on index 99. But the interesting part is that if I take this and I do type, this is actually a series. So what actually happens is that it takes each value of each series and takes the name of the series, and that becomes the index, and the value. So it actually takes that row and transforms in a series. And because of that, I can access, for example, satisfaction level, which is the first, 0 is the first of this series over here. So it becomes a little bit more tricky when you go to a data frame, but it's pretty useful, this function. Just gonna turn my light on.
I have a question here if you want to take it.
Sure. Yeah.
So if you don't use the in place, when you're, I think this was when you were renaming a column from numProject to numberProject, what's the name of the new data frame?
The new data frame?
Yeah.
So in this case here, that I didn't use in place.
Or the, yeah, or on the example where you did use in place, what happens when you don't use it, basically?
So this is created, but because I didn't assign it to any variable, it kind of doesn't exist. Like it exists in memory, but it can access it. So unless I actually explicitly say, for example, df1, and then explicitly put this inside a variable, and then I can like work with it, it kind of like stays in memory, but it doesn't really exist. Like you can't really do anything with it.
So it only exists for a second, while it only exists to print that table out, and then it's gone for all practical purposes.
Exactly. Any more questions?
That's it just now.
Okay. Another useful thing is to iterate to through each row. One important thing to say here before I show you how to do this is that a series and an array, because series and array, remember, is kind of the same thing. It's very, like, doing operations using the series method are much more efficient than iterating through each one of this, because iteration is kind of like an expensive process, while matrix multiplication, array multiplication, and this kind of operations are much faster. And especially because I'm not sure if I pointed out, but NumPy and Pandas, for that matter, they have a lot of things that are written in C and not in Python, so they can be very fast. So every time you have to iterate, especially if you're talking about a lot of data, be careful, like make sure that you don't have another way of doing that. Otherwise, it can consume a lot of time depending on the size of the data you're working with. But sometimes we need that. So I'm gonna show you how to do it. So basically, I have item and row. I think this is index. I'm pretty sure this is index. And I can use the method iterRows. So iterRows, we're gonna go on each series, and the return of it, remember that I showed you this return here? Each row in here, it's gonna be the same as this one here. So I can actually go and access, for example, row satisfaction level. Yeah, so it's gonna print, oh, it's gonna run forever. Okay. If I use this button to stop, the kernel is just like stop in the middle, it's not gonna finish it up. So basically here, each row is gonna take each line and it's gonna introduce this as this series here. You can see here, there's a lot of things. I'm gonna just comment it out too. Okay, cool. Okay, so now we talked about a lot of methods and functions of a data frame. Let's talk about like multiple data frames. So I created here 2 data frames. So I have, value 1, value 2. Great, so I have, you can see here that I have this ID here, which it would be one value and another value here. So there are basically, there are a couple of operations that you can use this to. So merge would be the equivalent, for those who have SQL, would be the equivalent of join. So in this case here, I'm asking, let's merge of the first data frame, the second data frame. I want you to consider this ID column. So I want to match the ID columns. And inner means that it's gonna only return the values where you find a match on both data frames. So you can see here that I have value 2 here as C, and I have value 2 here as F. The same for value 3, here, here, and here, and the value 4. But everything else, 0, 1, the 6, it's gonna be ignored. So this is pretty useful to join 2 data frames. Let's say if I put this left, it will take the values from df1 that are not found in df2 are kept, but then everything else is going to be filled with none. I have concat, which is basically just put it together, like just, you can see here that I have, for example, duplicated indexes, which is not super great, but sometimes you don't care. And so what I can do here, for example, let's concat. What I can do here is use a function that is reset index, and it's actually, oh, I had to call it. And it's actually gonna like redo it, and now I have the indexes as unique as they should be. So concat is pretty useful, especially if you don't care. You just want to like one on top of the one on the bottom of the other. So you can see here that everything from value 2 on value 1 is going to be none, and none the same here. And I have the same thing here, but instead of doing this reset index, I'm just asking it to ignore the index, because I don't know if you remember, but indexes should never change unless explicitly told, because we want to never forget the timestamp or the value that was there. So Pandas actually implement this in a way that for you to change an index, you explicitly have to tell them like, this should be changed. I don't care about these indexes. And one interesting thing here, I forgot to put this on this class, but is that I'm going to try to remember how to do this. Let's take the concat. So I have this here. So for example, in this case, let's say that I want this ID to be the index. I can say, I think it's I forgot the function. I think it's this. No, it's not this. Okay, sorry, I don't remember. But there is a function that we can actually, for example, let's say that we read a CSV and we have a column that is a timestamp, and we want to move this timestamp to the index. We can do that. And then we have the index that will never, ever change unless explicitly told. I'm gonna search on how to do that later. Okay, and these were data frames. We still have some time and one more notebook to go through. We have questions?
No, there's no Slido questions.
Okay, so I'm gonna go to the last one, Matplotlib. Okay, so this is the trio combo of libraries. So we have NumPy for the basis of the analysis, and NumPy and Pandas work super well together. Pandas for all this NumPy with steroids that I talked about, and Matplotlib is actually the first, I think it's the first library that implemented charts, and it's pretty useful, a lot of documentation as well. What we're gonna use, but because it's very extensive, I'm gonna show you just a little bit, which is this module pyplot. So as I told you, the same thing as NP for NumPy, PD for Pandas. It's very common to see that pyplot, matplotlib.pyplot to be shortened as PLT. And so we're going to use this from now on. And remember the Jupyter magic? We're going to do the Matplotlib inline so we can actually see the charts there in the Jupyter notebook. Okay, let's run this. Great. Okay, so let's take a look at this CSV that we just worked a little bit on the last time. We have a lot of things here. So the first thing we can do is, for example, let's say that I want to plot. So I'm going to use plt.plot. I'm going to pass a series. So in this case, I'm going to pass this series over here. And in this case, I just wanted to plot the first 100 numbers, 100 values. And I can use this fig size to actually change the size that it's going to plot. So, oops. Okay, so we can see here that we have something. If I change this, oh, I deleted. Okay. Let's change it, fig size. It's 15.5. Okay, so you can see that I can change it, make it bigger, smaller, adjust to the notebook. I could increase this and change it. So I don't have to care about the numbers and anything like it, just make it work. So we can use the letter R, for example, because I want to see it in red, for example. So there are a couple of colors there that you can use. Yeah. Okay, so there are a couple of things here. One thing is that I get really annoyed by this thing that it prints in here. So basically what I do is like I assign a random variable to it and it just disappears. But that is just my OCD here. Okay, we can also plot two things in a row by just saying plot twice. So in this case here, let's take a look. I'm taking the series. I wanted to plot the first 100 numbers with the color red, but I'm also asking it to plot, and let's divide this. Let's gonna take this. Oh no, my keyboard. Everything is broken. Okay. Okay, so with this, I have it here. Basically, I'm using a function from linspace, and I wanted to take the value of mean of my satisfaction level and another value of mean and create 100 values of that. So it's all the same. And the idea here is that I can actually plot the mean line over it. So what I did was basically create a vector that has the same size of this one here with the same value all the time. I just called the plot twice with different colors. So K is for black and R is for red. And that's it. So I plotted both things and it just understood. And I can use this legend passing in a list with two values, and it gives me a legend over here. So it's pretty straightforward. And again, you can use, and that's it. Okay, so Matplotlib allows a lot of beautifying it a little bit. So we have here plt.title for title, ipsum label, x label, legend, and grid. Grid is for adding these values over here, you see, this grid. But it's pretty straightforward in terms of like, you can beautify it as you like. Okay, we can actually use this function subplots for plotting two charts together on the same figure. So in this case here, what I'm saying is that I want a figure and I want to extract the two axes and I want it to be two rows, both, and the figure will have this size. Now, if I plot one on axis 1, you see here that in this case here, both plots were on PLT. So it's gonna plot on the same figure. In this case over here, I separated the axis into two rows, and so I can create two charts. So let's run this to see what happens. Great. So we can plot one on top of the other. And each one of them will work the same. So for example, I can come here and next to .title, I think. Oh yeah, it's a little bit different, I think. Oh no, it doesn't work. Okay.
I think you need to do set underscore.
Oh, thanks. Set underscore title, right?
Yeah, I believe so. And then it's actually a function. It's not a property.
Thanks. It's been forever. Oh, thanks. And here it is. Here it is. Thanks, Felipe.
By the way, we can use a break, very quick break, and I can explain a little bit about that confusion because it's a sort of confusion for all of us. Matplotlib has that name because it comes from MATLAB. And in MATLAB, you didn't have this nice way on Python of setting properties. So Matplotlib has two interfaces. The one that they call the PyLab that tries to mimic MATLAB, and the one that's called the object-oriented one, which is more high level. So Leticia is doing the more high level one that unfortunately inherited some bad syntax from MATLAB. So we're stuck with it right now. But the inspiration from MATLAB was worth it because it made a lot of people adopt Matplotlib.
Thanks. I didn't know that actually, which makes sense because
You're too young to know that.
Matplotlib. Thanks. You're too kind. Okay, and we have other charts. So plot will actually plot a line, but we have, for example, histogram, and we can pass the number of bins, which means like how small do you want the columns to be. I change the number of beans. Let's put it a smaller one. It's gonna make the oh my god, I forgot the name. This thing's here larger. The area of it. Okay, so I'm gonna stop right here. Do we have any questions?
No questions.
But I'll add a time check. We are 17 minutes away from the end of the hour. I'm sure Leticia is getting exhausted. The following hour, like we said, it's completely up to you. Us organizers might just start chatting among yourselves if you don't jump in, but or we might pick on you to say something on you, everyone. But it's also flexible. If Leticia and others want to keep going with questions, well, yeah, sure. But we need a break. So an official break. We all said we're stopped so that we can do anything to stretch our legs. I'm not saying right now, sorry, that at 2, let's have a break regardless. I mean, sorry,
yeah,
at the end of the hour.
Yeah, okay, great, because I was about, oh no, stop. I'm about to finish this and I have like 5 more cells and we're good here. Okay, cool, thanks. So yeah, so we have histograms, we have a lot of things. If you actually go to the Matplotlib's website, you can go here, I think it's on examples, and you have like a bunch, like seriously, a bunch of things. And like, there are so many examples. So it's a pretty powerful library. I'm just like, again, all these libraries, I'm just scratching the surface here. Before we go forward, I'm going to show you something that is a pretty useful function for data frames that and series. I'm sorry, that I love. That I didn't show before because here it's going to be really useful for us. So, for example, salary it has a value, right? Like it has a category, so low, medium, high. So this sometimes we won't be able to plot this because like they are categories. So we could actually create this small function that's going to convert the salary from this values of string to values. And what I can do is I'm going to take the series, the F salary, and I'm going to apply this function. So basically what's going to happen here is that this function here is going to be called for each value of the series. And what I'm going to have now, oops, see, I try to run a cell without running the cell, like it blows up. Okay, so what we can see here now that I have the same thing, but now I have values instead of like numbers instead of categories. And I can use this to plot. So I have it here. So I'm creating subplots, but I'm only using one. So this is kind of like, it's getting more complicated. I'm not going to spend too much time explaining this. But the idea is that you have an example on how to do something once you need this. But the idea is that now I can plot this directly with the categories numbers, for example. Okay, we have some, for example, pie charts, and yeah, so we can use, oh yeah, we have this function as well called unique, where we can basically take a series and get only the unique values from it. So it's pretty useful. Okay. I showed you a couple things here about Matplotlib, but as I told you before, Pandas launched the version 1.0 a couple of months ago, and it basically implemented inside Pandas a lot of functions of plotting that came from Matplotlib. So for example, let's take the last evaluation, just 100 points as well, and you use the function plot. So remember, this is a series. We're slicing the series here, and now I'm calling the function plot. If I do this, I get the same thing as with Matplotlib, and you can see that the style is the same because it's basically calling Matplotlib to print the series. And actually Pandas implemented a lot of functions. So we have this density, which is basically kind of a histogram, but we have a histogram as well. So and you can, and the fun part is, because they are all together, like NumPy and Matplotlib and Pandas, you can actually mix and match. So in this case, for example, I can call the fig size function to increase the figure, but then call the Pandas plot library and then use Matplotlib for title. So it's a mess, but I swear it makes your life easier. So here, I'm basically using Matplotlib and Pandas all together to put this chart together. Okay, last thing, and I promise this is fun. So I don't know if you know XKCD, which is a pretty funny, very nerdy comics thing. I don't know, what are the names? Comics, right? And so they have a very proper style of charts and everything. And they basically implemented, so this is the kind of charts they do. You see that the lines are very creaky and like the style is very unique. So basically, Matplotlib implemented this function called XKCD. And once you call it, every chart you'll ever make will look like this, which is amazing because sometimes charts can be boring and you can make it more fun, but you know, kind of useless if you want to do some academic research. But I really love this part, and you can actually go, I think if you go like Matplotlib and do XKCD, I think it's like this, everything becomes kind of XKCD, like even the examples, everything, gallery. You see, like, they all look like XKCD. It's amazing. I don't know who had the time to do this, but I love them. So I talked about this every time that I can. And with this, I end the tutorial. So
just to finish that, I know who wrote that. And
really?
People in Washington are probably familiar with him, Jake van der Pla, who was at the eScience Institute and used to teach Oceanhackweek with us in the past. But now unfortunately, Google got him. And we no longer have him.
What's his name?
Jake van der Pla.
Oh, okay. I know. Oh, really? He was the guy who invented. Oh my God. Okay. Seriously, I love this. I made so many charts like this, and I got roasted because I shouldn't.
And it is based on an R library, by the way. So you also have that on R.
Really? Okay, cool. So people who love R also can enjoy all these beautiful charts here. Okay, so that was it from my part. Again, super scratch the surface only. There's so much more to it. The documentation of all of these libraries are actually pretty good. So you can actually learn how to do data science in some of those libraries. So feel free to, I left on the README there are links to each one of them.